Alright, this video is for Unit 4, Lesson 3. Today in class we worked on a Desmos activity. So I would encourage you to actually go to student.desmos.com and complete that activity. Here is a class code that you can use for students that were absent. So I am going to give them points in class for completing this assignment. So if you'd like to make up that assignment and get those points for class, you can do this. This class code will get me that information that you have completed this activity. So this video is a recap of that. You should have done the activity prior to watching this video. Uh, the point of this activity is to get you to start connecting the standard form of a function with the intercept form and use that intercept form to start to understand some of the behaviors of the function on a graph. So polynomials are generally written in a standard form, but if you are able to factor the polynomial, you can put it into what's called an intercept form. Intercept form is the same as a factored form. So the x-intercepts of a function happen when the y value, or the value of the function, is equal to 0. So if we want to know the x-intercepts, we're asking ourselves, for which x does the function equal 0? So you can see here I have this function set equal to 0. And that tells me that the x values for those x-intercepts are -5, -1/2. Again, that comes from solving the equation 2x plus 1 is equal to 0. So you solve that for x, you would subtract the 1 and then divide by 2. And then this final intercept has a 0 at x equals 3. So these numbers, these values for x are sometimes called the roots of the equation, and or they sometimes are called the zeros of the function. Each of those corresponds with one of the x-intercepts on the graph of the function. So if we have a 0 at x equals -5, that corresponds to the x-intercept -5, 0. The x value -1/2 as a 0 of the function corresponds to the x-intercept -1, 0 as that point on the graph. So factored form really reveals to us what the x-intercepts of the function will be. Some factors in a function, though, have something called multiplicity. The multiplicity of a factor is how many times that factor appears in the polynomial. And so here's an example of a function that has some multiplicities. G of x is equal to x to the 5th plus x to the 4th minus 5x to the 3rd minus x squared plus 8x minus 4. That function in factored form looks like this. And we have an x plus 2 factor that happens twice. So typically we would represent that as a second power. That's a multiplicity of 2. And the factor x minus 1 happens in that function 3 times. So we would say that's a multiplicity of 3. So if we're looking for the x-intercepts of the function, we use that factored form to tell us that there is going to be an x-intercept. Since this factor is x plus 2, that intercept is going to happen at -2, 0. The multiplicity, if it's higher than 1, it affects the behavior at that intercept. If this is an even multiplicity, that's going to give you a tangent intercept behavior. If that multiplicity is odd, like 3 or 5 or 1, you won't see that tangent behavior. If it's a 3 or higher, you're going to see terrace behavior at that intercept. So this second intercept at 1, 0 would be a terrace behavior. And we'll be working with this a lot more for in the next 2 lessons. So during the Desmos activity, you were just supposed to start building and just the very basics of this idea that those multiplicities can affect the behavior at the intercept. This kind of summarizes that. If your multiplicity is even, if it's 2 or 4 or 6 or 8, it's going to have a tangent behavior where it touches and turns around. If it's a multiplicity of 1, those are the ones that just go straight across. No unique behavior there. But if it's a higher odd number, 3 or 5 or 7, that's when it's going to terrace. And the higher the power, the more flattened the terrace will be. You know, a higher power might be super flat looking for a minute. And that actually goes with the evens as well. It almost looks like it starts to get a square shape with those higher powers. So the fundamental theorem of algebra, it guarantees us that if a polynomial equation has degree n, it has n roots in the set of complex numbers, but some of those roots can be repeated roots. So the implications of this are that when we see a polynomial, we know exactly how many roots it has, and that's the same as the degree. The degree tells us how many roots. Some of those roots will be real, but others of them will be complex numbers or numbers that have an imaginary part. If a polynomial is factorable, you can find the real roots by factoring it. And if you graph the function, you will see the real roots corresponding to those x-intercepts. If your function has some imaginary roots, they aren't revealed by the graph, and we will be talking more about those in our next unit. Again, we'll be working a lot more with polynomial graphs and functions in our next 2 lessons. And that is a quick recap of your Desmos activity of the day.